Hello, good afternoon. Today we move on to the next part of progression. Okay, we just recap of what we have done. Progression, we have got two types. One is arithmetic and one is known as geometric progression. Okay, now for arithmetic, what we have seen is the concept of common difference. Okay, to find the term, the first n term, to find the n term, to find the sum of the first n terms. Okay, so there are three concepts here. So for each concept, there's actually one formula derived. This is to find your common difference. This is to find your t, the nth term, right? And this is to find the sum of the first n terms. Okay, so there were three concepts. Okay, now let's move on to geometric progression. Okay, now for geometric progression also, you have got three concepts. Okay, one is to find the common ratio, as I mentioned earlier, the common ratio. Okay, the second is to find the term that the question wants. Okay, the nth term. And the third concept is to find the sum of the first n terms. Alright, okay, now we will start with this. Okay, common ratio. For geometric progression, the concept here is called common ratio. Now, common ratio will be, the formula is actually Tn over Tn minus 1. Okay, I'll show you examples afterwards. It's a lot easier to remember. Okay, next is to find the nth term. So the nth term will be Tn equals to AR n minus 1, whereby A is actually your first term, R is your common ratio, n is the number of terms that we're looking at. Alright, so Tn equals to AR n minus 1. Okay, next is to find the sum of the first n terms. Okay, here for geometric progression, if you compare to arithmetic, okay, geometric we have got two of the S, sum. So one will be when R, your ratio is less than 1, so your Sn will become A bracket 1 minus R to the power n over 1 minus R. Okay, so that's when your R is less than 1. Okay, whereas if R is greater than 1, the formula just, okay, you just, the R and the 1, they switch places. So Sn becomes A, R to the power n minus 1 over R minus 1. This is when your R is greater than 1. Okay, now there's one last concept. This is for geometric progression and it's for this part whereby R is less than 1. Okay, to find the sum to infinite, the formula is, as infinite is A over 1 minus R. Okay, this is only valid when R is less than 1. Okay, alright, so these are some of the concepts that we are going to look at in geometric progression. So the first three is the same: common difference, common ratio. Okay, here to find the nth term. This is for AP, this is for GP. So we notice the formula is just slightly different. Okay, this is to find the sum of the first n term. This formula is for your AP. There's only one, this one. This one is when, remember this one, you know your first and your last, and we can actually simplify this formula to this. This is for your AP. Now, for your GP, Sn, you've got 2, depending on which value R takes. Is it less than 1 or is it greater than 1? Alright? Okay, the last is the concept of sum to infinite. Sum to infinite is A over 1 minus R. Okay, so we move on to some examples. Okay, the example will be, okay, now first thing first, we need to know whether a given progression is actually arithmetic or geometry. Okay, so here what we're going to look at is, I want to see or rather prove or show whether it's actually an AP, arithmetic progression, or a geometric progression. Okay, so for that, what we can actually do is, we use R. R is your common ratio. Okay, common ratio is It's what we have seen before, Tn over Tn minus 1. So this becomes, let's say I am using 2. So this is T2 over T1. The term after upon the term before. So this is 6 over 3. I actually get 2. This is for my first R. Okay, now for my second R, I'll actually take T3 over T2, which is 12 over 6, which is also 2. Okay, now just to double check, we check one more for R3. R3 can be T4 over T3. So this is going to be 36 over 12, which gives me 3. Okay, so the first one is 6 over 3 gives me 2. 12 over 6, 12 over 6, it gives me 2 as well. This is the same. Okay, the R is the same. Okay, now when we're checking for the third one, this is 36 over 12. So my R3 is actually 36 over 12 will give me 3 lah. So in this case, my R1 and R2 is the same, but it's not the same as R3. So R2 is not the same as R3. Okay, so therefore, this is not a geometric progression. Okay, just like your AP, your ratio must be common for all the terms that we're actually pairing up. Okay, let's try this now. Okay, we want to check whether this is actually a GP. So my R1 will be, I will take T2 over T1, which is actually half over 1, which gives me half. So that's my R1. Okay, for R2, T3 over T2, which is actually 1 over 3 over 1 over 2. So this is actually 1 over 3 times this one becomes 2 over 1. So it's actually 2 over 3. So in this case, it's already shown that R1 is not the same as R2. So once you don't see a similar value, so I'm sure we do not have to prove the third one. So straight away, R1 is not equals to R2. So therefore, this is not a geometric progression. Right? Okay. One more question. Okay. Now let's say I've got 2.7 and all this. Okay. Now to check my R1, this is T2 over T1. Okay, which gives me 0.9 over 2.7. Okay, so this one can be simplified. So we get it as 1 over 3. Okay, R2 will become T3 over T2. T3, 0.3, 0.9. So we simplify this and still get 1 over 3. Okay, last one is R3. R3 will be T4 over T3. This over this. So I actually get 0.1 over 0.3. So I actually get 1 over 3. So therefore here R1 is actually same as R2, is the same as R3. So therefore this progression is a geometric progression. Okay? Alright? Okay. So we move on to one more question. Okay, let's say the question wants you to find the first n term. The first n term. Okay, here you're not given a progression, but you're just given your A. This is your A, and that's my R. Okay, how do I do that? The formula is Tn is ARn minus 1. Okay, so n we do not know, so we just leave it as Tn. A is 0.3. Okay, my R is 1.5 and minus 1. Okay, so this can be simplified. 0.5. This is 1.5 n. Okay, times 1.5 to the power of negative 1. Okay, which can be simplified to, this is 0.5 over 1.5, and this is 1.5. Okay, so this will become This is 3, 15. So this is 1 over 5. 1 to the power 1 to the 1.5 to the power of. Alright? Okay. Okay, yeah. Alright, just one more example. So far what we have done is to see whether a given progression is actually a geometric progression. Okay, write the progression in terms of Tn given A and R. Okay, now this is just one more question. Okay, now the question says this is your given. This is a geometric progression that's given in the question. Okay, you want to find the number of terms. Alright, okay, so here what is given is I'm given my A is 20. Alright, okay, now to find my R, what I can do is I can just take T2 over T1. Okay, in this case, it is a progression. This is a geometric progression. So we do not have to prove it. So my R is half. Okay, now this is my last term in the sequence. So what I'm going to use is I'm going to use this ARN minus 1. Okay, yeah. This is my Tn, my last term, which is 5, 1, 2, 8. So I just add on here, given Tn is 5 over 1 to 8. Okay, my A is 20. R is half just now, and minus 1. Alright, okay, so this is half and minus 1. So we bring this down. This is 1 to 8. I bring it down, so this is times 20. Okay, alright, so this is 4. So I can actually get this in terms of, this is 1 to 8 and this is 4. So this is actually 2 to the power of 7 and 2 to the power of 2. So it's the same. So I'm actually adding this. On this side is 1 over 2 and minus 1. Okay, so what I can actually do is, this one can actually be written as 2 to the power 9. And here I can actually bring down the power. This is 2n minus 1. So when we compare your left hand side and your right hand side, base is the same. So 9 is n minus 1. Or I just switch it over. So n becomes 10. Okay, so that means now what you're trying to say is 5, 1 over 28 is the 10th term in the geometric progression. So that is what you're trying to tell us. Okay, so this is to find the number of n. Alright, okay, now based on this, what you can actually do is, okay, I want you to try these questions. Skill practice 11, question 1 and 2, and skill practice 12, question 1, 2, and 3. Alright, thank you.